Hi, my name is James Goodman. I've been working together with my teammate James Sample, and together we've created TramBee, a perfect travel planning app for getting around Manchester. Here's James with more.
We found the current Metrolink website clunky and not very user-friendly, so we wanted to create a simple application where users could get just the data that they were looking for. With our application, not only can you get accurate tram times for the Metrolink station in question, but you could also use the interactive map to explore restaurants, bars, and other attractions around your destination.
Hi, welcome to our app, TramBee. At the top you can see the nav bar, which has the home button to the interactive map, and a sign-in button for Google login. Beneath it is the tram line map for all the stops in Manchester. Beneath this is the reminder to sign in to log a favourite button, and beneath that is the tram stop selector. So we can click on this and we can select any tram stop and press get tram times. And that will fire off the request, and this will display the results. So here is the destination, and here is the time it will take for the tram to arrive at this stop. Beneath that is the service updates button we've included. Clicking on that will reveal any updates or possibly any delays on tramline. It can also be hidden. Go back up, if we click on either this button or sign in button, we'll go up to Google login. Click that to log in. Now we've logged in, we have our favorites button which has appeared. So currently the stop is set to Cemetery Road. If I press that, that will change and fire off a request to here. If I want to change my favorites, I can click on another tram stop and I can press the favorite this stop button. That will change that here and in the button. And again, pressing that, it will fire off a different request. We also have our interactive tramline map, which we've implemented. So we can zoom in and see the different tram lines. You can also see any other points of interest, such as shops, bars, hotels. So if you click on one of these, you can look further into it, see pictures. And just basically help the user plan their journey. So it's worth noting that we've made the page responsive. So we can click on here and have different client sizes, and everything will react and respond to the size. So everything will fit inside. The functionality is still there as well, changing tram stop gets different results. So log in and log out. I'll hand you over to James now.
The technologies we used for our front end included JavaScript, React for functionality, HTML for markup and CSS for styling, Google Maps for our interactive tram map, various NPM packages like Font Awesome and Toast, and Netlify for hosting. I'll now give you a quick walk through our front end code. Our front end is made up of a number of different React components. This is the app.js file, which has the functionality for the Google login. The user data is set in this bit of state, which is passed down into other components as a prop. The home.js file has the code for the landing page. This includes the tram map, the tram stop select capability, and the results. This function is the get request, which is sent out to the backend, which in turn sends a request to the TFGem API to get the data for a specific station. The return data is set in this bit of state, which is passed down into the results component. The get tram data function is passed down into the tram stop select component. This is where users can select a specific station. The stations are mapped in from a list of stations that we have in a JSON file. Once a station has been selected and passed through the handle search function, the window scroll function is called to scroll down and reveal the data that has been rendered. The results component is where we actually dissect the data that comes in. We wanted to make sure that we were getting and displaying the correct data, so we had to use ternary operators to do this. We also have a component down here which shows the data which is displayed on the message boards. This is able to be toggled on or off by the user as they wish. The add favorites component is where users can select a specific station that they want to add as their favorite station. We send a post request to the backend, which again sends a post request to the database and uploads a user's profile and their favorite station. There are a couple of warnings here. If no station was selected, then a warning pops up, or if the user was not logged in, a warning pops up. The favorites component makes a GET request to the backend, which again makes a GET request to the database and returns the favorite which has been set. The technologies we use for our backend included Node for running our application, Express for building our API, MongoDB for our database, Axios for communicating with external APIs, and then finally Render for hosting. I'll now give you a quick walk through our backend code. This is the code for our backend. We separated our controller functions into different files for easier reading. We also have a number of different parts here to different APIs and the connection string for our database, which is MongoDB and Atlas. The user login is handled in this component. We make an Axios GET request to the Google API that then returns some data which we send across to the front end to allow users to log in. Tram times is where we get the information from the TFGM API, again using an Axios GET request. We need to add the station as a query parameter, and we have the subscription key to ensure that the request is authorized. Once again, that data is sent along to the front end. Insert favorites is where a user will add their favorite station. Firstly, this will search to see if the user is in the database. If the user isn't, it will create a new user and add the station as their favorite. If the user does exist, it will update them with the new favorite. Fetch favorites is where we return the data that's already in the database, and that sends through the favorite station has been set already. The database schema is fairly simple, and we just have a user and a favorite, both as strings.
Hi, so in this part I'd like to discuss our project planning for TramBee. For planning the project we use three main apps, or two even. The first one is Figma, which is this. We just put out our initial ideas in note form there, and then we structured the notes into columns here, so what would be essential for the MVP, what could be added after that, and what was not essential but would be nice to add at the very end. And then after we structured them, we moved them over here and turned them into actions. So we took all the musts and put them into must actions, and the same with the shoulds to should actions here. And that transferred over to Trello. So that was the second tool we used. So we put all the musts into tickets in here, into a to-do column, moved them over to the doing column, and then moved them over to the done column when they're completed. So it's a list of our done tickets. And the same with the should list. And then finally, we used a tool called Izard, which was just very, very useful for helping us plan out visually what we would like the app to look like. As you can see, we've got like things from the map page or another map, a different version of the map page, the home screen when we're logged in, when we're not logged in, even the color layout as well, but it's similar to what we used. The use page, which we initially going to have, but we chose not to. The MVP, which is what we just want the basic thing to look like. How, and just refining afterwards, so the search results would look like, different ways to display them, what the favorites would look like, different ways to display the favorites. We also held frequent stand-ups to discuss the project almost every day, to check where our progress was, where we were against our Trello lists, what we need to include, what any blockers we were having. We mob and pair programmed as well frequently with each other, and as well with tutors whenever they offered help. We also used spikes to explore like potential solutions, weigh up like whether a certain route we're going down was worth investing time in, or if it was best to not go down that route and try something else that would be faster, or possibly just to cut out that thing and leave it for another time.
There were a number of challenges we encountered while building the application. The first being that the data returned from the TFGM API was quite convoluted. We also spent a number of hours dealing with asynchronicity and getting the wrong data through. The Google authentication tokens also caused us a bit of a headache. If we had more time, we'd have liked to expand the login functionality to add a few different methods of authentication. We'd have loved to put some geolocation features in there as well as getting some journey time functionality in so people could actually plan their whole route.
That's it from me and James. Thank you for watching our presentation, and thank you for all co-mentors and tutors.